Okay, we're at the final stretch of these notes, and the last thing is to know the difference between a rational and an irrational number. So the first one it says is rational numbers. These are numbers that can be expressed as a fraction. They can be a fraction. Any fraction you see is rational. It's a terminating decimal or a repeating decimal. Terminate means it ends. Repeat means it repeats. So, 1/2, this is a fraction. That's rational. It can be turned into this decimal. This decimal terminates. These are both examples of rational numbers. 5/4, it's a fraction. That's rational. It turns into a terminating decimal. That's rational. The number 2, it terminates. It ends. That is rational. Now listen to this next part. This is a perfect square under a square root. The square root of 16 is 4. Anytime you have a perfect square, and that's why you want to memorize those perfect squares also. Anytime you have a perfect square under a square root, it's going to turn into a whole number, and it is rational. And this last one, here's a fraction. It turns into a repeater, and those are always rational. Rational, rational, rational. The final one is irrational. Now, the most famous irrational number is pi. So if you can remember, pi is irrational because it does two things. Pi never ends. That's when you see these dots. These dots represent never ends. And it also can never repeat. If you put pi in your calculator, and pi is underneath the clear button, you have to press second caret. It's going to end on your screen because your screen only goes so far. But 3.1415926, yada, 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 never ends, never repeats, is irrational. And let's look at this other example. 3 is underneath a square root. It is not a perfect square. So, if you have a number under a square root and it is not a perfect square, you're going to say irrational. So, look at your difference between rational and irrational and the final ones on this note sheet. And I know this lesson was long today, but it's important. We're going to label the following as rational or irrational. So here we go. First one, 1/7. Think to yourself, what do you think it would be? I'm just going to use an R or an I. This is rational, and I'm going to put a reason. I see a fraction. 3 2/3. This is rational because I see a fraction. 25% can be turned into the decimal 0.25. That is rational because it's a terminating decimal. Square root of 48. Now you got to think, you just learned this today. Is 48 a perfect square? You have to turn your note sheet over. Turn over your note sheet. 48 is not a perfect square. So this is irrational. I see the square root of 4. That is 2. I see a fraction. This is rational because it's a fraction. -9 pi. As soon as I see pi, I say irrational because every pi is irrational. So the last row, I see pi. That's irrational. Even though the square root of 36 is a perfect square, you're adding it to pi, so that's irrational. Square root of 9, that's a perfect square. I know that's 3. 3 times 5 is 15. This is rational. What do you see in the next one? Hopefully you're catching on. This is pi. Pi is irrational. These last two you might need to put in your calculator. Cube root, last time. How do you find a cube root? You hit math, number 4. The cube root of 125 is 5. 5 minus 7 is an integer. This is rational. And the last one, square root of 5, that is not a perfect square. No matter what you're adding to 10, that will be irrational. I will post these videos. If you need to look at them again, you can find them in Schoology. Use your notes to do your homework tonight.